Sometimes it's helpful to let a machine store a piece of information, like a farm storing whether it's turned on or not, or even something more complicated, like a game storing a high score. While there can be ways around Redstone to do this, it can still be useful to know some of the techniques that go into doing something like this using Redstone, just in case you decide you feel like it, or it can have applications around Redstone as well. So that's what today is. Starting off with something fairly light and intuitive, storing and using different signal strengths to do things. Different signal strengths can be pretty easy to get, as you can usually just use comparators or natural signal strength decay in redstone wires. Storing them is a little more tricky though, since any use of repeaters will overwrite whatever you're trying to store with a maxed out 15. And redstone dust has to be used cautiously or you'll lose some strength somewhere. A pretty nice and fairly compact way to store signal strength is to use this little thing. Putting a signal into any of the dust will cause the system to store the strength of that signal by passing it through a couple of comparators, each powering the other through a block and a piece of dust. Because comparators pass signal strength through without changing if they're not getting any side input, these two will keep powering each other without changing their signal strength for as long as you need. If you need to reset the system so you can store another signal with a lower signal strength, or you just want to make it go back to zero for some other reason, that's what this piston is for. When it gets deactivated, it'll pull a block with it, taking it out of the system and breaking the loop. This forces both comparators to go back to the depowered state, resetting the circuit. To actually make use of a signal strength, you'll usually want to check the strength to see if it matches a specific value or range of values. One way to do this is to make use of logic gates from the last video, as well as redstone dust's signal strength decay, by checking if one spot on a wire is turned on, checking again on that wire a little down the line to see if it's off, and feeding those two signals into an AND gate. You can limit your output to only turn on if an input signal strength is between two specific values. To make this thing a little smaller, you can use the subtract mode on a comparator. Alternatively, if you just want to check if the signal is higher or lower than some value, you can also use a comparator for that, since that's kind of a part of their job. Another way to separate out signal strengths is to use a red coder. Red coders are circuits that take in signal strength and output a signal in a different place based on the strength of the input. These work based on the same idea as before, where you can check the same wire multiple times as a way to check signal strength. In the case of red coders, you're checking every place on the wire to see if it's a signal strength of 1 and giving an output if it is. This puts the only output on the wire at the point where the signal is about to end. These things can be bulky, but they can be helpful when you need them. Unfortunately, making use of signal strength has a lot of limitations to it. For one, there isn't really a good way to transport a signal while keeping its strength, because the only thing that's really able to do that is a comparator. Comparators are really cool and all, but transporting signals is not one of their strong suits. Because they have a one-tick delay, they can't power things upward very efficiently, and they can struggle in tight spaces. Because of this, it's a lot more common to store information making use of binary signals, basically just turning something on or off and reading it somewhere else to make use of it. There are a bunch of ways to store a binary signal, with most of them having fancy computer science names. I'll be using these names for the most part, but don't feel like you need to memorize them. It's more important to remember how they work than what they're called. Because of this, I'll also be providing a backup name in case you forget the fancy one. To start us off, we have the gated D latch, or the shortest attention span. These are pretty simple in their function. They have two inputs, the D and the gate. Anytime you power the gate, the latch stores whatever is running through the D. If the D changes while the gate input is turned off, the latch won't react at all and will instead just hold on to whatever it was holding onto before. I don't use these often, but I figured I'd mention them because almost everything has a use case with Redstone, especially when you incorporate the fact that different people have different preferences and stuff. I've only got one example for building a gated D-latch, since I just made one quick for this video, but it's pretty small and cheap, so I don't think it's too bad. All you have to do is point a repeater into the side of another repeater and put a redstone torch behind the first repeater. Powering the redstone torch will act as your gate input, and putting a signal behind the second repeater will act as your D input. This works by locking a repeater by default, meaning it won't update immediately based on any signal behind it, and will instead just keep going with whatever it's got. By turning this torch off with the gate input, you unlock the repeater, letting it update whatever it had stored before turning off the gate and relocking the repeater. Next up is the T flip-flop, or the Swappy Man. These are also simple. A T flip-flop has one input, and whenever that input turns on, the flip-flop turns its stored value off if it's currently on, and it turns the value on if it's currently off. It toggles whatever it's holding on to, hence the T in T flip-flop. I actually have an example for using these since I use T flip-flops more often than the gated D latch. My funky little example is as a counter. If you connect multiple T flip-flops in sequence and only trigger the first one, they'll trigger each other in a way that counts using the binary counting system. Otherwise, they can be used for normal information storage things just like any other memory circuit. As for how to build one, I have multiple examples of that, so I'll try to move quickly. First one is similar to the gated D latch, making use of a locked repeater, only the D input is always set to the opposite of whatever's being stored. That way, whatever you power the gate, the stored value will toggle. This specific design requires a short input, otherwise it'll turn into a clock for a little bit, but that can be achieved using a simple pulse shortener. Second one uses the fact that sticky pistons will spit out their blocks when powered for a redstone tick, and pull in a block if not pushing one. If a sticky piston is only ever powered using single redstone ticks, the block in front of it will swap places with each activation. If this block just so happens to be something that emits power, like a redstone block, this can be used as a T flip-flop. The third and final design for a T flip-flop I'm showing off here is a crazy one, so pay close attention. Step 1, place a copper bulb. Step 2, place a comparator next to the copper bulb pointing outwards. Congratulations, you are now the proud owner of a T flip-flop. This one is generally pretty good since it's compact and has very little delay, so I use it pretty often whenever I'm using T flip-flops. If toggling isn't your thing, then you may be interested in the SR latch or the Son-Roth latch. In actuality, SR stands for set reset because those are the inputs this thing takes in. Whenever you power the set input, the latch sets its value to be on, and whenever you power the reset input, the stored value is turned off. These are also really good pretty often, but I want to highlight how they can be used to make button panels that only use your most recent press. When any button is pushed, you can activate the reset on all of your inputs, then activate the set on one specific latch based on which button you pushed. I also have 3 designs for the SR latch, so it's time for another speed round. First design is similar to the signal strength storage thing, just using repeaters instead of comparators because we don't care about what signal strength we have anymore. We're only paying attention to whether or not there's a signal at all. Second one is another use of blocking repeaters by default to store signal. This time, both inputs unlock the repeater, but only the set input powers the line behind it. If you want to think about this in terms of the gated D latch, both inputs activate the gate, but the set turns on the D at the same time. Finally, we have a design that's very easy to think about where you just pass an item between 2 droppers. Pick a dropper to pull a comparator output from. Activating that dropper will be your reset, and activating the other one will be your set. You do have to be careful that you're not powering either of these droppers directly, though, because droppers are conductive blocks and will activate the other dropper if you do. One limitation of SR latches in real life is that you should never power both inputs at the same time, otherwise you'll get a result that isn't very optimal. A variation exists that fixes this problem called the JK latch, where both inputs being turned on signals the system to toggle the value being stored, like a T flip-flop. In Minecraft, this isn't super necessary due to most designs for SR latches not exploding if both inputs are turned on, so I don't have a lot to say for JK latches. Your nickname for these guys can be the just kidding latch, because that's kind of it. And with another video comes another awkward transition into the outro. I have been considering making videos that aren't as informational, like a more opiniony one, still about Minecraft, as well as a video showing off a game I've been making separate from Minecraft. So if you're interested in either of these, please let me know. Otherwise, if you want to see me design things with Redstone, also let me know. I can probably do that too. I already ran out of stuff to say in the outro, so I'll let you go. Just have fun doing some Redstone.